This is Mr. Anderson for Kellogg Community College. This is the second of two videos here for Chapter 2, Section 2. We're going to find some exact values from trigonometric functions of the given angle. Obviously, we're going to have some undefined problems because we could have some 90, 180, and 270 degree marks here that could have some division of zero errors. But what I want you to do also is keep in mind that you should probably have your unit circle video or unit circle worksheet out in front of you to use for reference. So the first angle we're looking at is 5 pi over 6. Now when we look at 5 pi over 6, that is actually on the unit circle itself. You can find it as you check here. This is the 150 degree mark here, and so at the 150 degree mark we can look at our sine, and our sine is going to be our y value, so that's 1/2, and our x value is going to be -3/2, and from there we can get all the other ones here as well. I will be kind of moving kind of quickly through some of these because we should have some of them pretty much memorized because we've had that as part of our objectives here. So this is our y value, this is our x value. Our x value is going to be -√3 over 2. So the inverse of sine is cosecant, and that's 2. Inverse of cosine is going to be -2√3 over 3. Again, I'm not going through the rationalizing the denominator part of it here because we have, we kind of have that. Been doing that quite a while. Here, this tangent is, if you can't memorize it, you can derive it by going y divided by our x, which is our x in this case. We skip, flip, and multiply, which is going to be 1 over -√3. And if we rationalize the denominator, it's -√3 over 3. I'm not showing the step where I multiply top and bottom by √3 over 3, but that's really what happens. Then if we flip this on its head, we would have 3 over -√3. Rationalizing that, we'd have 3 divided by 3 and our √3 in the numerator. So this again is made quicker if you know the unit circle rather than showing out all your steps to get what you need. Now 240 degrees is again on the unit circle. I will kind of flip back to that here. So 240 degrees are sine of 240, which is right here. Our sine for that is going to be our -√3 over 2, and our cosine is going to be -1/2. So let's flip back. Get the pen rolling here. So the sine, -√3 over 2, and the cosine is going to be -1/2. The flip of this is going to be -2√3 over 3. It's if you did the whole thing out by flipping this on its head, multiply top and bottom by √3 over 3. The secant is going to be the flip of this, -2. The tangent is going to be taking our y value, which is our sine, and divided by our x value, which is our cosine, but I got to flip it. Oh, shoot. Alright, so that's going to be 2 over 1, crisscross simplification. This is a positive √3. And if I flip this on its head, so 1 over √3, rationalizing that out is √3 over 3. Again, the faster these problems, you'll go faster because you will get to them. You'll get to them just by knowing the unit circle and making good on your work there. 11 pi over 4 is a bit interesting because it doesn't, you might say, oh, it's not on the unit circle, but it's actually on the unit circle, but 11 pi over 4 is part of the unit circle if you travel around the circle more than once. So 11 pi over 4, it really goes, now remember here, every fourth is 45 degrees. So this is 1, 2, 3, 4, 5, 6, 7 pi over 4, and this is 8 pi over 4, then 9 pi over 4, 10 pi over 4, 11 pi over 4 is right here at 135 degrees. So that's 11 45 degree marks right there to get to 135 degrees. So this is where I'm going to get my sine and cosine. Now, notice that my sine is the y, which is -√2 over, or positive √2 over 2, and my cosine is my x, which is -√2 over 2. So let's go take a look here back on the worksheet, and you can see I'm having trouble clicking that. And you're wondering, like, well, hey, Mr. Anderson, why didn't you put your 11 pi over 4 right there? Well, it became kind of a formatting problem where Microsoft Word every couple seconds wanted to like change the formatting here. So just imagine that all of these is 11 pi over 4 in the middle there. Okay, so the sine of 135 degrees is going to be our positive square root of 2 over 2, and our cosine is our negative square root of 2 over 2. And we can come up with all these. This tangent is negative 1 because this is y over x. Any number divided by itself is 1, but it's negative because of this. The inverse of this is going to be square root of 2, because if you flip this on its head, it's 2 over square root of 2, multiply top and bottom by square root of 2. Then you get the 2's to simplify, and this is going to be negative square roots of 2, which means our cotangent is going to be also negative 1. Okay, so what we're going to do for 11 pi over 6 is we're going to take, go all the way around, or this is going to be, 13 pi over 6. We are going to look at going from the 11 pi over 6 to 13 pi over 6. Now, every pi over 6 is going to be every pi over 6 is going to be like 30 degrees. So this is 11 pi over 6. This is let's see here. 11 pi over 6 is right here, sorry. 11 pi over 6 is 30 degrees, so here's 12 pi over 6, and so therefore 13 pi over 6 is just here at pi over 6. So this is the same thing as 13 pi over 6, because this was 12 pi over 6, this is 11 pi over 6. So what I'm going to do here is I am now going to say what is my sine and cosine of 30 degrees, which is easy because the sine is 1/2 and the cosine is square root of 3 over 2. All right, let's go back to my other worksheet here. All right, so back to square root of 13 pi over 6, which is the same as 30 degrees. This is going to give me 1/2. And this is going to give me square root of 3 over 2. And the cosecant of 13 pi over 6 is 2. This is going to be 2 square roots of 3 over 2, or sorry, 3. And then we're going to work with our tangent, which is going to be our, again, if you can't memorize it, just take our y over x. And this might be just enough for you to get you over the hill here, because this is going to be 3 square roots of 3 this is going to be square root of 3 over 3, and this is going to be, sorry, I'm trying to do this in my head here, multiplying top and bottom by square root of 3 over square root of 3 gives you this, and then flipping this on its head is going to be square roots of 3. That is our cotangent of 30 degrees. This is our tangent of 30 degrees. All right, 390 degrees. Well, 390 degrees is the same thing as the 30 degrees, because you'd go around you'd go around the circle, 360 degrees, and 360, from the 90 is equal to 30. So the answers are going to be exactly the same. So these two answers are going to be exactly the same. Hooray! Just showing you an equivalent way to get around the unit circle there. Now, moving on to negative pi over 3. So if you look back at the unit circle, negative pi over 3, if you take, since pi over 3 is 60 degrees, we can do the 60 degree swing right here. So 5 pi, it's equivalent to 5 pi over 3. So at this location, our sine is going to be, let me move back to the other screen. So we're going to be looking at 300 degrees here at 5 pi over 3. And this negative pi over 3, again, at 300 degrees, or negative 60 degrees, whichever way you want to think of it, this is going to be my negative square root of 3 over 2, and cosine is going to be 1/2. Flip these, and this is, remember, that's negative there, so this is going to be 2 square roots of 3 over 3. And then we get to our tangent here. Again, if you have trouble deriving it, here's our y and x, and that makes our negative square roots of 3, and the inverse of this is going to be square root of 3, negative square root of 3 over 3. So again, you can work all these out if you'd like to by just flipping this on its head, but you could see that you're going to have, if you rationalize the denominator, this is your cotangent of negative pi over 3. Negative 240 degrees is the same thing as 120 degrees. So if we go to our unit circle at 120 degrees, and you can put your sign of negative 240 in here if you wish. You can also put in positive 120 if it's equivalent, since it's equivalent. But our sign is going to be square root of 3 over 2, and our cosine is going to be negative 1/2. And that gives us, if we do the reciprocal here, we have 2 square root of 3 over 3. And what we have here is positive 2, or sorry, negative 2 because of its quadrant location. Then the tangent of negative 240 degrees is going to be, for this case, since we have one positive, one negative, we have negative square root of 3. And again, we have one positive, one negative here, so this is negative square root of 3 over 3. Notice the similarities between these two locations at positive 120 degrees and here at our 5 pi over 3, or same in this location. Okay, so moving down to our last two here. We got our good old friend 5 pi, which is, let's see, I wonder where 5 pi is on the unit circle. So let's go take a look. 5 pi on the unit circle, starting here at 0 degrees. So every single 180 degree measurement is a unit of pi here. So we have 1, 2, 3, 4, 5, 180 degrees. So what we're going to do now is go back to our other worksheet here. It's my blank screen here. There we go. Go back to our worksheet here, and now we have our unit of 5 pi. Okay, so 5 pi. What is that? All right. So let me go to this here. All right, so 5 pi is going to be, sorry, I'm having a little technical difficulties here. Things on the menu didn't show up there. So the sine of 5 pi is the y value at that location at 180 degrees, and that point was negative 1 comma 0. So our y value was 0, our x value was negative 1. The inverse of these is 0 and negative 1, which is pretty straightforward, except that the inverse of 0 is not 0. The inverse of 0 is 1 divided by 0, so this is undefined. I know the book says not defined, but I like to put undefined right there because 1 divided by 0 is not defined. Now, the tangent on this case here, the tangent on this case is going to be 0 because this is y over x. So 0 divided by negative 1 is 0. But the cotangent is this on its head, which is also undefined. Alright, so that gives you your 5 pi for each of these right here. Again, I didn't write them in because I was having some spacing issues there. Now, negative 13 pi over 6. It's kind of funny that you mentioned that because if you look at problem 20, that was a positive 13 pi over 6. Now, an equivalent measurement to negative 13 pi over 6 is going to be actually 11 pi over 6. This is actually equivalent because if we went around the unit circle backwards 13 pi over 6, we would end at that space. I'll show that to you on the unit circle right now. So here we go. Oh man, I'm having trouble switching. There we go. So if we go 13 pi over 6 in the reverse direction, here's 12 pi over, like if we brought my marker up here, this is 12 pi over 6 right here. Now if we go an extra pi, this is where we would be. We would be at this location here, or at my negative 1/2 for my sine of negative 13 pi over 6, and we would be at my square root of 3 over 2 for my sine of negative 13 pi over 6. So, back to the worksheet here. There we go. Going a little slower. It seems to work a little better here. Alright, let's draw on this screen here. Okay, so the sine of negative 13 pi, sorry, that's a little sloppy, over 6. The sine is going to be negative 1/2 for its location, and the cosine is going to be positive square root of 3 over 2 because it's a positive x value. The cosecant is the inverse of that, and this is going to be 2 square roots of 3 over 3. Then we do our tangent. Our tangent, again, if you don't have it memorized, you take your y and divide it by your x. Here's your x, which gives you negative 1 over square root of 3, which will then simplify to square root of 3 over 3. Our cotangent is the flip of this, which is going to be negative square roots of 3. And again, I'm just not showing all the work there. But the last part is the part you get to use your graphing calculator on. And I would strongly recommend when doing the calculator portion, is that you pay close attention to the mode that your calculator is in when doing them. So what we're going to do here is we're going to take our calculator and use it to find all of these approximate values within 2 decimal places. So the first thing I need to do is always check what mode am I in. Now this is in degrees, so I make sure I want to click the mode and change this to degrees. And do so by clicking the mode on your calculator, hitting enter, because the default is radian when you first get your calculator. So we're going to then quit out of that by hitting second mode, and we'll type in the cosine of 14 degrees. And the cosine of 14 degrees rounded to the nearest thousandths is 0.97, or 97, sorry, not thousandths, hundredths. 97 hundredths is the approximation of cosine of 14 degrees. Now let's do the cotangent of 70 degrees. Now we're going to take our tangent of 70 degrees, and let's go evaluate that. And since the cotangent is the inverse of that, 1 divided by the tangent of 70 degrees. Now I like to go second negative to get my answer, so I don't have to type in that whole decimal. The answer is 36 hundredths. An alternative to doing this, two-step operation is you could just type in this for your cotangent as well. Now the next problem is in radians. So we're going to have to click our mode and go back to radians, and then from there click second mode, and then we can type in the sign of pi. Let's get our pi by clicking second caret divided by 8 and close that off and get an answer of 38 hundredths. For rounding to 2 decimal places. And then cosecant is 1 over sine, so let me just simplify by doing it this way. This is the cosecant of 5 pi over 3, so let's go 5 pi divided by 13, sorry, not 3. And then we get an answer of approximately 1.07 hundredths. Alright, so let's go with tangent. Now, the question is, you notice that there's no symbol here? This means it's the tangent of 1 radian. So there's no degree mark there, so it's 1 radian, and that means the answer is going to be 1.56 hundredths for your approximation. Now, when you want to go to degrees, you're going to do the same thing, but make sure you change your mode to degree. And doing so, you can just hit the enter key, because that would actually do the same thing as tangent of 1, which gives you approximately 2 hundredths, 0.02 as a decimal. All right, thank you for watching.